Hello everyone! Last time we created a fairly interesting fire shader effect that works well in 2D games. This time we'll try transforming it into a 3D shader, put it on the surface of a cylinder and observe the results. So let's get started. This tutorial is essentially a kind of response to comments on the previous videos. I agree that so far I focused mainly on 2D shaders, while 3D didn't get as much attention as it would deserve. I'll try to correct this imbalance a bit this year. So let's start by demonstrating, using this example, one way to convert a canvas item shader 2D into a spatial shader 3D. So I'll create a new 3D scene and add a world environment so we can set the background to black and better observe the fire effect. Right-clicking the scenes folder, create a new scene. It is a 3D scene this time. Let's call it fiery area. Okay, and as I said, right-clicking, add a child node and the world environment. Let's go to the inspector, create a new environment, click it and set background to custom color, which is by default black. Okay, and as I mentioned at the beginning of the video, we'll take the finished shader, this one, which I previously called wildfire, duplicate it and modify this copy for use on the surface of a mesh instance 3D. So let's expand the shaders folder. Oh no, this is better. Right-clicking the wildfire shader and show in the file system. Definitely faster. And Control D to duplicate, and let's call it fiery area. All right. Now I'll find it here. Where is it? Here. Fire. Here, this is one. Okay. So this is the shader we've been creating in the previous video tutorial. First, we need to change the shader type to spatial. Spatial. Okay, and we immediately see that the code cannot compile because, let's expand this window and scroll down, because a spatial shader does not use color, but albedo and alpha instead. So I'll modify the corresponding line in the fragment function like this. It would be albedo equals color, because albedo is a vector 3, not vector 4, like the color variable in the canvas item shaders. And as for alpha, we can simply take this part, which we use to set up the transparent background, and let's delete the original line. Okay, what exactly is wrong? Alpha AVG, alpha threshold 0, 1, unknown identifier, alpha, sorry. Okay, this is correct. All right, so that solves the main issue, and we can try out how this effect looks. So let's show the area again and switch to 3D editor. Since we want to create a circular area with fiery walls, the most suitable primitive shape is, of course, a cylinder. So I'll add a mesh instance 3D and set it up. Right-clicking the root node, add child node, the mesh instance 3D. Let's go to the inspector and set the mesh as the cylinder mesh. Here it is. We can see a new cylinder in the scene. It's lit from one side by the default light. It might be better to move its base to the origin level. Now it's just in the middle, so we can simulate an effect that lies on the ground rather than below it. So I'll select again, and in the inspector, transform position Y, let's set to 1. Perfect. Now it's correct. Okay, so to use the shader, we need to add a material. So I'll click on the mesh, and first let's select the mesh instance 3D again, and here in the mesh I'll click it, and the material property is right here. Let's click it and new shader material and click it again. And we will simply drag our fire area GD shader into this property. Okay, here it goes. So we can see that something has appeared, but it's definitely not correct. A flame is displayed on the top base of the cylinder, whereas we would expect it on the bottom instead. I'll get to that in a moment, but first let's fix the issue where the fire is visible only on the lit side of the cylinder. Our effect shouldn't depend on scene lighting, so we'll set the render mode to unshaded. In the shader code, let's scroll up, and after shader type spatial, let's write this render mode unshaded. Okay, wait for it. This is already a bit better, just a bit. Next, we need the fiery walls to be visible from both the front and the back, because, as you may remember from the previous video, our effect is partially transparent. By default, Godot has a backface culling enabled, which means it does not render faces whose normal vector does not point towards the camera. So we'll disable this with another render mode parameter called callDisabled. callDisabled. Okay, now we can see both sides. But there are also some strange artifacts appearing inside the cylinder, which change as I rotate the camera. That's because the blend mode is set to blend mix by default, while we need additive blending. So I'll add one more render mode parameter called blend add. Blend add. Okay, now it's correct. That solves all the rendering issues. The only thing left is to fix the correct mapping of the shader onto the surface of our mesh. Well, what we need to do is to replace UV coordinates, which we know from 2D shaders, with something more feasible. The core problem is that UV coordinates are just flat per-face texture coordinates. They have no awareness of the mesh 3D volume. To get a convincing 3D fire shape, we need to think about it differently. Fire is a volumetric phenomenon, so we want to drive the noise with object space position instead of UV, and shape the alpha fall-off based on the actual geometry rather than a 2D mask. So, what will this change look like in practice? To work with a position in space, we first have to obtain it in the vertex function and then pass it to the fragment function. For this kind of data transfer, we'll use the varying modifier, with which I'll define a variable called object pos. So let's scroll down just after the uniform parameters and write this. Varying vec3 object pos. Okay, now I'll add the vertex function before the fragment function right here. Yes, the same vertex function that I delete at the beginning of almost every tutorial. Inside it, we'll retrieve the position from the internal variable called vertex. So void vertex, and inside object pos equals vertex. Okay, that's it. Now we can add a new line at the beginning of the fragment function. Vec3, let's call it pos for position, is simply object pos. That was modified in the vertex function, which is called before fragment function, so it already contains the correct value. As I mentioned, we'll also change the way we calculate the mask for rendering the fire. For this purpose, I'll add two new uniform parameters, one to define the horizontal radius limit and another for the vertical limit. Let's scroll up and go here and add these mentioned parameters, uniform float width with hint range, and let's start at 1. And it should go from something non-zero, so 0.1 to, let's say, 5 with a step 0.01. Okay, and I'll copy and paste, rename it to height. Great, with the same parameters and same default value. Okay, let's get back to the fragment function, to the beginning, and add two new variables inside it. These variables will use these new parameters together with the smooth step function, which is a common technique for clamping values to a desired interval, like this. Float, let's call it radial, is 1 minus smooth step, because we'll start at the center of the circle and go to the edges, and the range is 0 and our width parameter, and it's applied on the length of the position and xz components of this vector, because we want to work only with the x and z axis. This is plane. Okay, this is the radial, and now the vertical. Float. Vertical is simply smooth step applied on, a height parameter, then negative height, and just position dot y. All right, and now we can delete the previous calculation. Everything with UV and mask and other things, just until the fire definition. Let's delete that. And of course, we need to introduce the mask and the p vector. So let's do it. Float m is in this case simply radial times vertical, and vec3, the point P, would be position multiplied by scale factor, just like before, and let's subtract this vec3, 0 times speed times 0.01 and slice. Okay, so basically this is what, as we can already see something in the 3D editor, this is what ensures that the flames will be animated in the vertical direction. That's why we use the time variable only in this y component of the vector. Okay, so I guess we've achieved something really usable. However, it would be better if this bright part at the bottom appeared only near the ground. So I'll add 1 to the y-coordinate of the pose vector. Pose y is increased by 1. All right, yeah, now I think we've now achieved the same effect I showed at the beginning of the video. Of course, we cannot create true 3D file this way, because a material can be only applied on the surface of a mesh. And in our case, that's just a simple cylinder. To get real 3D flames, we'd need to model an object with a volumetric fire in something like Blender and then manipulate its vertices to imitate real flames. But something tells me that in such a case, it's much easier to use a particle-based solution, which I've created before and linked in the video description. So, what's left? Let's play around with the shader parameters and observe the results. I'll select the machines in 3D again. Let's scroll down here to shader parameters. And okay, let's increase the speed. Now it's going up faster, or change the number of octaves. As we can remember from the previous video, when I set octaves just to 1, we can observe the triangular wave basis, which is basically the core of our algorithm, or amplitude start. Now we can definitely shape the fire even further, or change in the similar way. Frequency, more grainy, less grainy. Distortion, okay, another a bit unusual effect. And scale. So for example, if I set the scale to 0, this is just another kind of effect which could find use in certain games, I'm sure. All right, or this one. Okay, and as for slice, this is simply slicing through the 3D fractal, so we just change its structure. Okay, as for width, let's decrease it. Now we can see it's only inside the cylinder, now it's outside. or the height. Let me just show more of that and increase the height. Yeah, and we can see that it never goes outside the boundaries of the cylinder, of course, because the shader is always applied on the surface. Okay, and as for as sorry, alpha threshold, it gives us another kind of effect. Yeah, very nice. Okay, let's get back. Of course, instead of manually editing the code, no, sorry. If we wanted to change the color of this effect, we would simply adjust the hue calculation when calling the HSV to RGB function. I'll just show how to do it in the code, and of course, if we want to make it more simpler to use, we would create one or two new uniform parameters. So for example, this is the hue part. Let's change it to 0.6. It should go to a shade of blue or violet. 0.3. Now this is green. Okay, very nice. Let's get back to 0.9. And of course, we can increase the saturation. Now it's 0.6. What about 0.9? Yeah, definitely more in the red shades, and the brightness is already set to 1. So what if I change it to 1.5? Yeah, it's brighter. Okay. And of course, we can do any kind of these experiments through the GD script. So our fire effect would be modified depending on the situation in our game. Thank you very much for watching. I think this kind of effect would work well in a 3D game. For example, to mark a magical area that teleports the player the moment they step into it. Or it could represent an impenetrable magical barrier if we map it onto a quad mesh instead of a cylinder. There are plenty of possibilities, and everyone will surely discover what suits them best. I have to say, I already started to enjoy working with shaders in 3D, so you'll definitely see more 3D shaders on this channel. And for now, take care, good luck with your projects, and I'll see you in the next video.